Welcome to everybody for this closing sessions. Very proud to be invited here. So I will share with you this unprecedented wave of change, which I renamed a tsunami because it's even more than a wave, it's a huge wave. So I will show what are the fundamentals of that and how we react in Thales Alenia space to handle this change. Just a very short, brief history of SATCOM, where we come from. We come from a period decades ago where satellites were used in C-band to build international links like fiber optics today. They were used also for maritime communication because when you're in the ship, you have no link with the ground except if you have a SATCOM over your head. They have been used progressively to broadcast TV or to broadcast content and video because they are very good at that. You send one signal and it is received by potentially millions of people at the same time. It was used also for VSAT with broadband communication to have internet access a bit everywhere. And this developed with the development of internet in what we call HTS or VHTS satellites, high throughput satellites. So this is where we come from. And all these are starting to be a bit shaked, a bit in competition with the terrestrial networks. At this time, at the region of SATCOM, the telcos, Orange in France, Telefonica in Spain, or AT&T in US, were part of this SATCOM story because it was just another network for communication. But they have realized that it was a niche market, and the niche market was not key for them, so they have withdrawn from this interest in space. And in fact, they have they decided more or less to compete against the SATCOM. And we see that the fiber optics across the oceans have developed. And so the intercontinental links through satellites have become more like a redundancies approach, but not mainstream. ADSL developed a lot to connect the houses with internet. Even in Europe, in high-density areas, you have a fiber to the home that is bringing 100 gigabit per second at your premises. Do you hear well, or is it? Yeah? Okay. And this is, of course, a very efficient mean to deliver broadband internet, and satellites are not as efficient today. And the mobile network also developed a lot, even in rural areas where you could also have some connection of the house with mobile communication. So the first wave of competition against satellites was provided by terrestrial networks. Then the user, in fact, is the guy who decides, because this is you and me that decide each month where you want to put a few tens of euros to have your internet access or your TV programs and so on and so forth. And the users decided that the TV that was a bit linear, so you look at the information and the news at 8 o'clock in the evening, and then the film at maybe a bit later. This is not anymore the way we use TV most of the time, except if there is a football cup or Olympic Games. You look whenever you want the program you want. And satellites are a bit less adapted to that because their big strengths in GEO is to broadcast same content to millions of people. So we need to rethink and readapt the satellites to better serve what we call non-linearized TV, which is using the program you want whenever you want, and stop it when you want to stop. So Netflix is very successful, but is not a big friend of satellites today. So this first wave, we are used to that because we have seen that coming for many years, and we try to adapt and to nevertheless develop the space offer in this co-opetition context with the terrestrial networks. But the biggest wave is coming from the US. We have seen Elon Musk project in SpaceX, very efficient on launchers because he's launching almost every day now, and he has been also very, very efficient on terrestrial, on the constellation that is almost able to compete with some terrestrial networks. The full design of this approach is around a terminal, a very cheap terminal with active antenna and quite advanced silicium germanium technology. I know you are all microwave experts and much more expert than I am, but the bright idea was to design a terminal that mass-produced will be much below $1,000. When I was in ISAE, you remember I was there 30 years ago, active antenna was a dream. It was very nice, very fancy, very flexible, but we dreamed that the cost of each active module could drop below 1,000 euro for one module, but you need 1,000 of that to make a nice antenna. Now the full antenna is costing less than $1,000. And so the big success is thanks to clever design, nice technology, very integrated technology, and mass production. They can drop the cost of the antenna and make it a mass market success. And when you have this tiny antenna, you need many satellites and a quite a low altitude, 600 kilometers, in order to have the good link budget and to make that a commercial success. So the number of customers is ramping up. And this efficient and successful system is shaking the full ecosystem. First, our customers, because our customers wonder whether they can still buy quite expensive satellites and try to compete against that. And so they also concern the full supply chain, because if there is no more order of big satellites or systems, all the supply chain is suffering. And this is just Starlink, but Kuiper from Amazon is coming. And the same project, the same type of approach with almost the same engineers, because some have moved from SpaceX to Kuiper, and they will just redo the same in Ka-band instead of Ku-band. And this has not started yet, but with the power of distribution of Amazon, that is exceptionally well known on the planet, they can deliver anything anywhere, we believe that this will again be a very massive success for the mass market. But they will maybe not stop on the mass market, because they can also address business to governments, business to vertical markets like aeronautical communications, like maritime communications. And so we see that they are, based on the very good success on the commercial consumer, they also expand their success on other niche markets that the satellites were addressing. So we are at the point where we need to react. We don't cry, we don't complain. We just need to fight and to find good ideas and good systems in order to find growth again, because the number of geostationary satellites that were above 20 some years ago is...
The time is 4:30 and the European is now closed. See you all next
bye-bye. So we just need to rethink the added value of our services, and this is the goal of my next slide. So in order to be efficient on how to redesign our systems, we need to think in terms of user requirement. What do the user need? What can make them be interested in a given service? So the range of service that satellite can bring depends on the DNA of satellites, what they can bring to the world, to the planet, and it depends on the service. There is an increased need of mobility. We all have a smartphone in the pocket, and these smartphones cannot be connected to satellites today, except with some startups in the US. But this is a big move that will come, and this is what we call the direct-to-device. This is a device, a car is a device, a ship is a device, so we can connect all that with satellites. I will come back on that. The TV needs to be reinvented. By adding the caching approaches and the broadcast of satellites, you can mimic what things that you do with the internet, and you can reinvent broadcast satellites that will be very efficient economically, and that can broadcast the Netflix wherever you want. The broadband to consumer is the worst area, because we have already Starlink and we have Kuiper coming, so this is an area of the market where it will be the most difficult to reinvent a solution and to build new satellites. But we have still some ideas that I cannot share and broadcast here, but we'll still fight on this market segment. The broadband to business and governments is a bit more secure, because governments tend to favor local industry rather than global industry. And some constraints of security and sovereignty are very important, and so we can also find growth in this area. For the defense, we clearly see a growth in this area. Unfortunately, the world is less secure than before, and many countries that were not interested in satellites are willing to buy their own satellite. And we also work with a lot of technological efforts on new services that the satellite can bring. For instance, in optical, I don't know if you address optical communication here or if you stop at millimeter waves, but optics is coming. Of course, there are some difficulty to surmount, which is optics will not go through the clouds, but with sufficient number of ground stations, you can still feed satellites with terabit communication. You can also have data relay from observation satellites. We think about putting some data center or edge computing capability in space. The business model around that is not yet completely convincing. We need to be sure that it's worth putting this hardware in space rather than putting it on the ground. But we see some interest of the telcos because there is just no more room on the Earth to put this data center. There is such a growth in this field that some of them say, well, put them upstairs in the air and it will be much better for me. And quantum is also quite fashion, I would say. There is a lot of public money coming on quantum key distribution, on quantum communication. It's not a mass market today. Honestly, we don't receive an RFP for a quantum satellite every day, but there is a huge investment on the planet, and we prepare the next generation of satellites that will propagate this quantum information. So now I will focus on a few markets of these market segments to share with you some of the projects we're working on to prepare the next generation of satellites. Starting with a direct-to-device. We started many years ago. In fact, it was in 2015 when the iPhone 6 went out. We discovered how much money Apple is winning just selling iPhones over 1 month. And it's enough money to fund one full satellite constellation. So we started to invent the constellation that Apple could buy in order to connect the iPhones. So we started 10 years ago, nearly 10 years ago, to invent the constellation that can speak with these very small devices, very low power, because we don't want to burn our brain, so it's very limited power. But it's feasible thanks to a very large antenna. You almost build the satellites around the antenna, and you can close the link budget in a data rate that will be a few hundred of kilobits per second, not megabit and megabit, but enough to send a phone call, to have a small video or a WhatsApp. And there are a few projects on the planet to try to shape a sustainable business plan to offer this connectivity to anybody on the planet. It's a low band because it's much better for propagation, and these terminals, these smartphones work today in a band around 1-2 gigahertz, not more. It could move to C-band in the long term. If we unleash the regulation about C-band, it could one day also provide this communication with smartphones in C-band. Above, it's very unlikely. If we move to another market segment, the business to consumer. There will be a competition in the coming years between the LEO, Starlink and Amazon Kuiper, and the GEOs. The GEOs today, I take the example of the Connect VHS spacecraft, can put in orbit for something like 250 million euro a satellite that is half a terabyte. And if you calculate the cost of each terabit per second or each megabit per second you can serve for the user, you find it that it's at the same level of pricing as the LEO constellation. And the terminal cost can be even cheaper because the terminal cost can be around 200, 250 euros. So the GEOs can still compete with Starlink with a slightly different positioning in terms of service because the quality of service is a higher latency and lower cost of terminal. So we'll see how the competition is going. Today in the US, these GEOs are suffering a lot, but also because the operators were used to have huge margins. And when you're used to have very big margins, an EBITDA of 70, 75, 80%, it's difficult to drop your margin in order to be more competitive and more aggressive, because if you drop your margin, you drop your share value on stocks. And it's a difficult move. But the GEOs are still competitive against these mega constellations, in particular because the fill rate of a GEO, when it's flexible, it's fully digital, you can sell 100% of the capacity. Whereas on the LEO, there are high density area, very low density area, and it's impossible to fill LEO constellations more than 15-20%. So even if it's very cheap, the fill rate is very bad. And the trend in terms of frequencies for these GEOs are serving the user in Ku or Ka band and having the gateways to feed them in Q and V band, which is very nice for advanced microwave research, and also potentially tomorrow in optical. And this KVHES is having 16 feeders over Europe in Q and V band. Other market segment, business to government. So we are here in Europe, and this is a time where Europe is about to decide and to launch a very ambitious project called IRIS². I'm sure if you read the press, you have seen things about that. So we are in the very final discussion with operators, with European Commission, with Space Agency, to launch this project that will be a concession between Europe and a pool of operators, among them Eutelsat, SES, Hispasat. And it will address mainly the business to government, and it will also host communication for private uses. And the operators will embark additional capacity in Ka-band and in Ku band in order to serve their market. So this will be a big momentum in Europe with a lot of technologies to validate, a lot of terminals. This will be a backbone of heavy developments in digital RF and satellites in Europe over the coming 4 or 5 years. MilSatcom, well, it's very often very secret, but what we can say here is that we see popping up here and there new needs from various countries. And those needs are both very high-end. We are used to that. When we build a Syracuse satellite, it's a quite expensive, very robust, very hardened product. But we see countries that have less capabilities, less financial capabilities, that nevertheless want their own sovereignty, and they want their own asset, which usually is a geostationary satellite, because with a limited budget, you can buy 1, 2 satellites. You cannot afford a constellation unless you have billions of dollars. So this market remains on the geo orbit, and there is a very wide range of frequencies used by the military, from UHF up to EHF, 44 gigahertz. So it's also very interesting because they are more and more demanding in terms of throughput, in terms of total capacity, in terms of mobility of the terminal. So it's a vector of integration for the technologies, and it's usually very interesting to work for them. There is a trend to mimic the commercial trend to have always more throughput with very tiny devices, but keeping the security and the robustness of the communication. Last slide, last snapshot about the new services. Here we developed a lot of technologies in order to prepare new applications of space, with the vision that the business models around that will one day be effective. My last topic is on software-defined satellites, because geostationary satellites are lasting 15 years. And when you have to predict what will happen in 15 years in the field of telecommunication, it's almost impossible, because the horizon of visibility and predictability is maybe a few years, but not 15. So we were requested by our customers to build satellites that can completely change their market segment, change the service they offer during their lifetime. And it means changing the mission. You start with a TV, and if the TV is declining, you move to broadband. You change the location of the satellite because you have a market here, and tomorrow the market has moved in another continent, so you move your satellite. Changing the location of the gateways, changing the connectivity between the gateways and the user. Bref, changing everything except the frequency band. They would dream also to change the frequency band, but RF is RF, and when you have an amplifier in Ku band, it's not so easy to make it work in Ka band. So we explained that this is maybe the next step for you to work, but today we try to select in advance at least the frequency band in which the user will work. And so we invested a lot since a few years on this new generation. And I'm happy to share with you some of the pictures of what it gives. And this type of satellites is able to address various market segments. It's commercial today. It could also serve military requirements tomorrow by slight adaptation of the frequency band. And I'm sure you are keen on hardware. I will just show you a few slides of hardware where we are today before my conclusion. So these are elements of the payload of Space Inspire. Where you see active antennas in receive, active antenna in transmit. You see a very huge processor that is processing the full bandwidth and capable of doing digital beamforming. We had a trade-off, analog beamforming versus digital beamforming, and we can do both, but given the number of beams and the flexibility that was requested by the customers, we opted for the fully digital beamforming to generate as many beams as needed. And this will fit on the platform, and you see that the quite large size of panels on which we are starting the integration, so the first Space Inspire will fly in a few years. And to conclude, and motivate you to go back after this this very interesting week, I suppose, to everybody's job. My conclusion is that the technology that you developed is absolutely key, because it's thanks to this very advanced, very integrated technology that we can build as integrator, we can build solutions that bring services to the customer at an attractive price. We need to bridge the market vision, what the customer needs, and what we can deliver in terms of technology to meet the good price point and the good value-added services that will enable the SATCOM industry to find growth again, even in a very, very competitive environment. So thank you to all.
Boulc'ch? Does it work? Yeah, okay.
If you have any question,
yeah.
I can answer. I cannot answer everything, but feel free to ask.
So, any questions from the assembly? No?
I was boring, so.
There is one question there.
Hi, thank you very much for the very interesting talk. I was wondering if you see any role for photonics in antenna beamforming. In this case, you talk about broad reconfigurability of frequency, software-defined satellites. I wonder, do you see any role for photonics with the extremely broad bandwidths could be achieved?
A short answer is yes. A longer answer is we tried, as we have photonics skills in Thales Alenia space, we try to match these photonics capabilities because they're very, very integrated, they're very tiny, low consumption, into our satellites. And either for the repeater, because we can change the frequencies in photonics, or for switching, where there is a capability to have very, very efficient switch in a very small area. One of the difficulties we found is on filtering, because photonics is not very good for filtering, and in most of our satellites we need filters. So we use photonics today in our processors. Maybe you have not seen because it was too tiny, but the interconnection between the boards are in photonics. But we have not found today the way to replace completely the RF or the digital by photonics because of this filtering I would say penalty, and also because of the unbalance between the efforts we do on RF, the efforts we do in terms of R&D on digital, and the efforts we do on photonics. Because there is a one order of magnitude, at least, of difference of investment in our company on that. But if we can leverage on investment done for photonics for other applications, we are more than happy to leverage that and use this technology when adapted to our needs. To, for instance, have beamformers in photonics, if we can do better in photonics than we do in digital or RF.
Thank you. And if I may, what is the issue with photonic filters? Is it about dynamic range, or is it about
given the specifications that we have for our customers, we found that the filters we could benefit were not adapted. Because we need sometimes very, very narrow filters.
Thank you.
Any other question? I do have one, but if we have some from the attendees. Yeah, so my question is, we have a lot of constellations that are being built, and my question is related to the space. Do we have space for all of those, and also the spectrum? Do we have enough spectrum to have all of those working together?
This is a very good question. On the press, you see a lot of constellation projects, as if the space could host them. but the business could hardly host them, and the frequencies neither. So for us, there is a big race to have successful constellations. The race is already started since a few years, and if I mention Kuiper and Amazon, it's because I'm sure that those constellations will be launched and will be successful. There is likely room for 2 other constellations in the same bands, because you can harmonize, coordinate 2 other constellations, one in KU, one in KA. We believe it when you are the 3rd constellation to try to find a way to operate without jamming the other constellations, because it's a first arrived, first served. So when you come late, it's difficult. You have to turn off your satellite when you are jamming the others, which is a penalty on the business plan. So this is why our best guess is that there will be 2 constellations in KU to maintain competition, and I hope OneWeb will be one of those constellations for Europe. 2 constellations in KA, maybe Lightspeed will succeed. Chinese are also trying to push constellations. We don't know yet what will be the name, what will be the frame, the frequencies, but there will be a big battle. And this is why RE2 is so important, because it's a way for Europe to also benefit the constellation in Ka band and potentially also in Ku band.
Yeah, first come, first serve.
Yeah.
Any chance for another questions? Yes, please.
Okay, thanks for the explanation. From a business point of view, okay, at Leo, so you mentioned there will be a lot of constellation. All this traffic, don't you see it as a risk for the satellite constellation at Leo? I mean, do you think that this will create crash at that orbit? And this is an advantage for the GEO operator? And do you think in the long term, is there a future for GEO?
Very good question. There could be crashes. We hope that they will not happen. The orbits in the LEO constellations, you have the LEO high and LEO low. LEO high is above 1,000 kilometers, and you can serve the globe with something like 200 satellites, more or less. It can be 300, but with a limited number of satellites, you can have a global coverage. If you are in LEO low, which is the orbit selected by Starlink and Kuiper, around 600 kilometers, you need 4 times more satellites to have a global coverage, because you are just 2 times closer, and the field of view of each satellite is much smaller. So they are closer, they are much more numerous, so the risk of collision is increased. So I would say for LEO high like RE2, the risk of collision is very, very low or negligible. The more the lower you fly, the more satellites you have, the more risk you have. But the LEO high is very hardened satellite, because there's already radiations and a quite severe environment at this altitude, whereas at 600 kilometers, the level of radiation is quite low, so you can use more COTS, commercial off the shelf, and you can build satellites a bit like cars. And this is also potentially a factor also for lesser reliability and more damages. Then for the GEO, yes, we foresee a future for the GEO. It's a question that at each satellite panel is asked to our CEOs, do you still believe in the GEO? We still believe in the GEO, but with a shrinked market, and we want to be one of the survivors in the GEO. This is why we invest like hell on satellites like Space Inspire. The market will be smaller, will be partly governmental, a bit less commercial, but among the principles or idea I shared with you, not in detail because they are part of our strategy, we develop approaches to bring the GEO great again, to make the GEO great again.
Thank you very much, Mr. Le Boulc'h. So we would like to actually thank you for coming to our community, and we have a gift for you that we'd like to offer.
Thanks a lot. It was a pleasure.